All right, so I'm only going to go over a few of these questions that I gave to you guys because I went through all of them in class, and anyone that repeats, I'm only going to go through one of them. This one I'm just going to go over real quick because remember, you have to use your graph and calculator for this. So I'm just going to go through the steps. The first thing you'll do is you'll press your stat button, and then you're going to click your edit button, and this will then bring you to a page that has a bunch of different lists on it, list 1, list 2, list 3, list 4, etc. In one of these lists, you will put your midpoint, and you'll fill in your midpoints. So for this example, it would have been 2, 5, 8, 11, 14, and 17, because remember, you need to find your midpoints of your class limits in order for you to find the mean and the standard deviation of your group frequency. And then in the other list, you will put your frequency. So for this one, it will be 6, 8, 10, 7, 0, and 5. All right. Then after that, you will press stat again. And then now, in this case, you will scroll to the right until you get to calc. And then you will press one variable stat. And it will bring you to a page that looks like this. It will say list, frequency list, and calculate. In the first list, you will put your midpoint. So in this example here, it would have been L1. In your second list, you put your frequency, which in this example, it would have been L2. And then you press enter to calculate, and it will give you your values. What you will need to know, the symbols, you will need to know your standard deviation, your mean, which is this symbol here, and your standard deviation, which you'll use this symbol, because remember, whenever we use a group frequency, it's always a sample. All right, and that's what you'll have to do. Now, on this question, not only will you need to be able to get the answer, but you'll need to be able to say, describe your steps you took to answer on a calculator, because I'm more concerned with you being able to use a calculator to answer this than the actual answer itself. So the steps here that you list out will be worth more points than the actual answer. All right, now the next one is you're going to be finding the weighted average. And when you find the weighted average, because if you look here, someone might just say, oh, determine the average number. All right, the question's not written, but if it says determine the average number of best friends each student has, they might just add 0, 1, 2, 3, divided by 4 and say that the answer is 1.5. But that's not correct, right? Because there are more students who have one best friend than there are who have no best friend. So we need to accurately weigh that. And what we do is we multiply each of these numbers. So this gives me 8, this gives me 12, this gives me 15, and this would give me 0. And we would add those up. So this would then give me 35. And then we add up the total number of students. And this will then give me 22. And then we take the total number of best friends and we divide it by the total number of students. And that will give me approximately 1.6. So that means each student has around 1.6 best friends, right? Because what this is saying is we have 8 students who said they have one best friend. So if we actually list out this data, it would look something like this. And we have 6 students who said they had 2. We had 5 who said they had 3. And 3 who said they had 0. So if I ask you to find the average of all of these numbers, you know how to do that because we've done this already, and you show me you know how to do it. You would add all that up and divide by the total numbers you have. Well, that's what we're essentially doing when we multiply, because if we add 1 8 times, it's the same as saying 8 times 1. If we add 2 6 times, it's the same as saying 6 times 2. If we add 3 5 times, the same as saying 3 times 5. And adding 0 3 times, the same as saying 3 times 0. So this is adding up all of the data that we have, and we divide it by the total number of people that they surveyed, and it gives us that each person has about 1.6 best friend. All right, so for this one, it's saying which data set is more variable. So remember, when it's saying that, we need to compare the two. So it will be newspapers, and it will be age of pilots. So it will be pilots. We need to compare. So remember, there's a saying that says it's like comparing apples and oranges, where they're saying you can't compare the two. Well, statistics allows for us to do that. So we can then compare the standard deviation against the mean for both of these. So we do the formula standard deviation divided by mean, and then we times it by 100. So then we will do 4 divided by 12 for the newspaper, because it's a standard deviation of 4 and a mean of 12, times this by 100, and this will give us approximately 33%. For the pilots, we will do 6 divided by 37, and we times this by 100, and this will give us approximately 16%. So the smaller the number, the better the standard deviation is, because it means that our data is not spread out, or our data is consistent, or it's less variable. So in this case, though, it says which one is more variable. So that means we got to go with the larger number. So that means that the average number of newspapers for sale is the more variable, because the number was higher than the average age of pilots. All right, so now this one's a little bit different, because now we're trying to say, we're given 2 tests and a person who scored on these 2 tests, and saying which class was his relative position higher. So we're trying to compare his score to his classmates in each of his classes. So it's not necessarily that because an 82 is higher than a 58 that he did better on that test, because we're trying to say, or higher than a 53, we're trying to say which one did he perform better and compare to the rest of the people who took the same test. So there's a general science test that was taken, and there's a psychology test that was taken. And in order to do this, you take the value that you're looking at, that you're trying to test, you subtract the mean, and you divide by your standard deviation. So the first one will be 76 minus 82 divided by 8. So this will then be -6 divided by 8, which is -0.75. So that is our z-score for the general science. And then for the psychology, it is 53 minus 58 divided by 3. And this one will give us -1.67. So when we're doing this, whichever one is greater is better. So this -0.75 is greater than -1.67. So that means he scored better on his general science test relative to the rest of his classmates, because he was closer to the mean. This is telling us how far we are from the mean. So since both of these are negative, that means both of them were less than the mean, but since this one was closer to the average, it means he scored better than this one here. Because when your standard deviations are, so since we are -1.67 standard deviations away, that means that he was actually further away from the mean than he would if he scored a -0.75. All right, so that's why this one's better, because it's greater, meaning he scored better than more of his classmates than he did on this one here. All right, so for this one here, when we're trying to find a percentile for a value, we need to first list our numbers in order from least to greatest. So in the question, I asked you to find a percentile for 0.9 and 1. We're only going to do one of them. So we're only going to find a percentile for 0.9. All right, so what we do is we count the number of values that are less than it. So 1, 2, 3. We then add 0.5 to that and divide by the total number of values we have, which is 8. And then we multiply this by 100, and this gives me 43.75%, but we round up in this case because it's 0.7, so that means that this falls in the 44th percentile. Right, so when you're asked to find a percentile, you need to rank them in order from least to greatest. You count how many are less than the number you're looking at. You add 0.5 to it, divide by the total number of data that you have, multiply 100, and then you round your decimals like you normally would, whether if it's down or up, and that's your percentile. Right, that's it for A. We're going to move on to B. For B, we're given the percentile. We're saying which value corresponds to the percentile. So we need to use the formula n times p divided by 100. So n represents the total number of values that we have, that's 8, and then percentile was 40. We divide it by 100, and that would then equal to 3.2. So now when we're given the percentile and we're trying to find the value, we always round up. So this rounds up to 4. And this tells us how many places or how many digits we need to go to, or how many data sets that we need to go to. So we need to go to the 4th data. So this is 1, 2, 3, so that means 4. So our answer for this for the 40th percentile would be 0.9. All right, there's one other kind that I'm going to go through with this one. All right, now what if this question, instead of saying 40th, it said 50th percentile? Well, we would still follow the same formula, n times p divided by 100. Now it would be 8 times 50 divided by 100, which is now equal to 4. So in the other example, we had a decimal, and we always round up. Now, if we get a whole number, we have to do something a little bit different. We still count to that number, 1, 2, 3, 4, but now we take the number after it, and we find the average of those two numbers. So it's 0.9 plus 1 divided by 2, which is then equal to 0.95. So that will be your final answer if I ask for the 50th percentile. I'm going to skip C because I'm going to do a different problem with you later on with this, so I'm just going to skip C for now. All right, so for this one, when you're given where they tell us a bell-shaped distribution, as they tell us here, we know that we need to deal with this problem here. All right, so I will give you this on the test, but you need to fill out your mean goes in the very middle. So our mean is 1019, and our standard deviation is 110. So we need to add that every single time. So this would then become 1129, 1239, and 1349. So we add that, and then as we move to the left, we're going to subtract it. So that will then give me 909. Then that will then give me 799. And that will then give me 689. All right, so now it says, what percent of the scores would you expect to fall above 1129? So we need to highlight where 1129 is. So here is 1129. So falling above it, we need to add all the percentages that go greater than that. So that would then be 13.5 plus 2.35 plus 0.15. And that would then give us 2.5 plus 13.5, which would then be 16. So that means 16% fall above 1129. All right, then the next one, it says above 799. So 799 is all the way down here. So rather than having to add all of these up, I know that my percentages have to add to 100. So I can then just add 0.15 plus 2.35, which is 2.5, and I can do 100 minus 2.5, which is then equal to 97.5%. And that would be my answer for above 799. All right, there's one other question I'm going to go through, and that's graphing box plots. All right, so for this one, the directions may say something like the number of cars sold at a specific car lot or at a car dealership in Cairo versus Alexandria. So these are the number of cars sold each day on specific car dealerships. So what we would do if we're asked to plot a box plot for both of these, you still need to find your Q2, your Q3, your Q1, your lowest value, and your highest value. So you need to find that for both. So for here, our Q2 will be 6. Our Q1, we would then have to average these two together and divide by 2, so that's 3. Then we would add these two together, divide by 2, it's 8. Our highest is 9, and our lowest is 1. So we would plot these. So our lowest value is 1. Our Q1 is at 3. Our Q2 is at 6. Our Q3 is at 8, and our highest is at 9. Our Q1, Q2, and Q3 we make into a rectangle or a box. That's why it's called a box. And then we draw a line going through our Q2, and then we connect a line connecting our lowest and our highest values. All right, so that's the box and whisker for just Cairo. All right, so now we need to do the same thing for Alexandria. So that would be Q2, Q3, high, Q1, and low. Well, our Q2 will be the number in the middle, so that's 7. The average of these two for Q1 will be 5. The average of these two will be 11. Our highest value is 12. Our lowest value is 4. So we would plot these. Now, when you are graphing two box and whiskers on the same graph, you need to put them above each other. So there's our lowest value. There's our Q1. Our Q2 is 7. Our Q3 is 11. And our highest is 12. So we would then draw a rectangle connecting our Q1 to our Q3. And then we draw a line going through Q2 and we connect Q1, or our highest and our lowest, right? And then what you would need to talk about is how they're skewed. I mean, we can say, we can kind of try and talk about these in different ways, but all you really need to be able to do is say this one, since it's closer to the left, it is skewed right. And this one, since it's closer to the right, it is skewed left. Right? And then you might be asked to just say a little bit more about what you think is going on between these two and try and read them a little bit. I'm not going to go through right now and give you those examples. I want to see what you guys can come up with as you're going through the test. All right, that is it for this review.